So problem 32, once again a confidence interval problem. So it's one population. It's about p hat, those kind of things. That means it's about proportion. And hence here n equals 5792. Number of success x equals 3139. So p hat is x by n, which is 0.5420. Now we want to find a 95% CI, but to find 95% CI, we need to check something. I'm sorry that we missed to do this, but the thing we need to check is whether n times p hat, that means x, is bigger than 5 and n minus x is bigger than 5. So in the previous problem, n was 81 and x was 22. So 22 is bigger than 5 and 81 minus 22 is also bigger than 5. This we'll do it now also. So here x is 3139. That's bigger than 5. And n minus x, that's also bigger than 5. So that's something we have to do. That being done, the rest is as usual. So for c equals 0.95, zc equals 1.96. So the formula for E is zc times p hat, square root of p hat q hat by n, which will come out to be 0.0128. So that's your margin of error. So this E is your margin of error. Your p hat is the point estimate. And the confidence limits are p hat minus E and p hat plus E, which if you calculate comes out to be 0.5292 and 0.5548. Okay, so question 33 and question 34 is about the same kind of things, but they're asking a different question. So it's about finding n. So this kind of things we have already done, but in a different context. So if we look at question number 27, I'm sorry. If we look at question number 27, we have done this again, like here. So if it's like 85% and we want E to be like 10, then what should be small n? What should be sample size? So we are doing this kind of things again, but in the p hat context. So here, all right, let me first write down the formula. So E is ZC times square root of P hat Q hat by N, which if you invert will become square root of N is ZC times square root of P hat Q hat divided by E. So N shall be ZC by E whole square times P hat times Q hat. So that's kind of the formula. And this is the formula I'm talking about. So in the other context, this was the formula for problem 27 which we applied. But for this P hat this kind of business, this is the formula I'm talking about. Of course, they are talking about P here, but I mean, you can see like what's going on. Now, for part A, they want C to be 0.99. That means ZC is 2. ZC is 2.575. Of course, they want E to be like 0.05. And they're also saying that if no preliminary study is made, all right, so we have no idea what P hat and Q hat are. So if we have no idea, actually we have no idea about P, then what you do is you put in P hat equals Q hat equals half. That's your strategy. So then you shall say N equals 2.575 divided by 0.05 whole square times half, and this will become 663.0625. I mean, you can say N equals 664. You always take the higher number. And in part B, if a preliminary study indicates 57% are female, so that means they know that. So now so the same remains. ZC is still 2.575. E is still 0.05. But now P hat is 57%, which will mean Q hat is 0.43, and that shall make N equals 2.575 divided by 0.05 whole square times 53% times 57%. Times 43%. Again, sorry. Which shall come out to be 650.06, and you can make it N equals 651. Next problem. Same kind of thing. Let's do it. By the way, you can find here C equals 85%. That means ZC is 1.435. How did we get this? We have already done that. All right, so here E equals 0.03, and we have no previous estimate in first part. That means you shall put p hat equals q hat equals half, and that will give you n equals zc by e whole square times p hat times q hat, which is 572.0069. So you can actually call it n equals 573. In next part, ZC is still 1.435. This is part B. 1.435. E is still 0.03, but now you have p hat. You can input p hat to be 0.28, and hence q hat, which is 1 minus p hat, that to be 0.72. Hence n equals zc by e whole square times p hat times q hat, which will come out to be 461.2664. So you can go ahead and say n is 462. So for now, we have done up to problem 34. For problem 35 to problem 40, we'll not do it now. We shall see how much we can do in class. So based on that, we'll decide somewhat our next steps. For exam 2, I may or may not keep problems 35 to 40. I'll see about that. I'll see what I can do.